Could there be life on Kepler 22b? Will we ever find an exoplanet just like Earth, with oceans, trees, animals, and maybe some kind of humanoid aliens? How will this planet be? Maybe it will be smaller than Earth, maybe bigger. Astronomers are now looking for these kinds of planets, but it's not so easy to spot them. With the help of our current techniques, we're able to spot a lot of massive and large planets, but it's way harder to detect Earth-sized ones. Of course, there are some exceptions. The first planet to ever be found similar to Earth was Kepler 22b. It was detected in 2009, and today we know this amazing planet is orbiting in the habitable zone of its host star. But what's a habitable zone? And what are the main features of Kepler 22b? Could there be life on this planet? Let's find out. First of all, how do astronomers find an exoplanet? There are actually various techniques, but the most used are direct imaging, radial velocity, and transit method. As of today, we know that different techniques are more sensitive to different kinds of planets. For example, the direct imaging technique makes use of large telescopes fitted with adaptive optics, which boosts their performances to directly image an exoplanet. This technique is most sensitive to the warmer, younger, and more massive exoplanets that have very stretched orbits. In fact, the more stretched an orbit is, the bigger its angular size in the sky, and the easier it is to spot it. The radial velocity technique makes use of the well-known Doppler effect. Astronomers basically employ a spectrograph to get the host star spectrum. Since the star and the planet are bound to each other, they're both going to move around their common center of mass. This means that during an orbit, the star will move back and forth. This kind of harmonic movement will show in the spectral line shift, the Doppler shift. The technique is most sensitive to exoplanets with a large mass orbiting close to their host star, perpendicular to the plane of the sky, because these massive planets attract the star more, causing the amplitude of the harmonic oscillation to be bigger. The last technique, one of the most used and efficient, is the transit method. This is actually a game of lights and shadows. The exoplanet is detected by measuring a periodic decrease in the flux received on Earth from the host star. In fact, imagine having a star and looking at it. At a given time, a planet happens to cross the stellar disk. What you would see is sort of a small eclipse of the stellar disk, where the luminosity of the star decreases as a consequence of the exoplanet transiting in front of it. This technique is the most sensitive to large exoplanets orbiting close to their host star. In the case of our planet, Kepler 22b, the transit technique was used. The telescope employed for this kind of study is the famous Kepler Space Telescope, a powerful instrument for searching for exoplanets. Kepler discovers planets and planet candidates by measuring dips in the brightness of more than 150,000 stars to search for planets that cross in front or transit the stars. It requires at least 3 transits to verify a signal as a planet. What makes Kepler 22b so special? Well, it was the first planet confirmed to be in the so-called habitable zone of a star. This is defined as the orbital region around a star in which an Earth-like planet can possess liquid water on its surface and possibly support life. Liquid water is essential to all life on Earth, and so the definition of a habitable zone is based on the hypothesis that extraterrestrial life would share this requirement. Of course, for a planet to host life as we know it, it's not sufficient to only have liquid water on the surface, and further studies are needed, but at least it's something. So let's see what we know about this possible Earth twin. We know it's located 600 light-years away. While the planet is larger than Earth, its orbit of 290 days around a sun-like star resembles that of our beautiful world. The planet's host star belongs to the same class as our Sun, called a G-type, although it is slightly smaller and cooler. The brightness Kepler 22b gets from its star is about 25% less than the one we get from the Sun. We also know that Kepler 22b is the smallest planet yet found to orbit in the middle of the habitable zone of the star, similar to our Sun. Just to give some numbers, its radius is 2.4 times the radius of Earth. Scientists don't yet know if Kepler 22b has a predominantly rocky, gaseous or liquid composition, but its discovery is a step closer to finding Earth-like planets. Finding planets the size of Earth or smaller is no picnic. In fact, as we said before, most of the current and modern techniques allow us to find massive planets, large in size and with highly eccentric orbits. But from time to time, scientists happen to be lucky. For example, other small planets orbiting stars smaller and cooler than our Sun recently were confirmed on the very edges of the habitable zone, with orbits more closely resembling those of Venus and Mars. Fortune smiled upon us with the detection of this planet, said William Borucki, Kepler principal investigator at NASA Ames Research Center at Moffett Field, California, who led the team that discovered Kepler 22b. The first transit was captured just 3 days after we declared the spacecraft operationally ready. We witnessed the defining third transit over the 2010 holiday season. Just to understand what we are talking about, take a look at this plot. On the x-axis, we have the semi-major axis of the planet, which means the distance of the planet from the host star. This increases as we move from the origin to the right. On the y-axis, we have the planet's mass. It increases upwards. The shape represents the various detection techniques. As you can see, the transit method and the radial velocity method are the ones that, as of today, can help us find the less massive planets, if they are very close to their host star. Hey, if you're still here, it means you're really enjoying the video. Why don't you subscribe now and press the bell notification? The NASA site on the Kepler mission estimates the mass of this planet to be 36 to 124 times the mass of the Earth. Considering the range of possible masses between 6.36 and 124 Earth masses, but in these cases the most probable mass is always the smallest, it's also easy to obtain the interval of the possible surface gravity, which goes from the most probable value of 1.11 g to the exorbitant and improbable value of 21.5 g. However, if we use the only data we have, if the planet was composed of the same elements that make up the Earth, distributed in the same proportions, then it would have a mass of 13.8 Earth masses and a surface gravity of 2.4 g. But we know this planet's diameter is 2.4 times that of the Earth. This might tell us Kepler 22b has a different composition from that of Earth. Some astrophysicists say it could be an ocean planet, but what do they exactly mean with that? An ocean planet would be a planet consisting of a rocky core, surrounded by an extensive mantle of ice and water, on which a vast surface ocean extends. Can you imagine? If you were to live on Kepler 22b, you would have to swim a lot. However, it is possible that it has a composition rich in volatile elements in its outer envelope. This would make the planet the smallest known gaseous dwarf. Kepler 22b is really close to its host star, much more than Earth is to the Sun. But the brightness of the star is lower than the solar one. If we combine these two parameters together, we can say the planet has a moderate surface temperature, which would be ideal for life as we know it. Of course, everything depends on the atmosphere. In its absence, it would be really cold, something like minus 11 degrees Celsius. But if an atmosphere existed, and if the planet had a greenhouse effect similar to Earth's, the planet would have a nice average temperature of 22 degrees Celsius. The Kepler science team uses ground-based telescopes and the Spitzer Space Telescope to review observations on planet candidates the spacecraft finds. The star field that Kepler observes in the constellations Cygnus and Lyra can only be seen from ground-based observatories in spring through early fall. The data from these other observations can help determine which candidates can be validated as planets. From what we know, Kepler 22b is not the only planet found in the habitable zone so far. Kepler also has discovered more than 1,000 new confirmed exoplanets, nearly doubling its previously known count. A bunch of these candidates are near Earth size and orbit in the habitable zone of their host star. Candidates require follow-up observations to verify they are actual planets. Of the 1,780 confirmed planets beyond our solar system, as many as 16 are located in their star's habitable zone, where conditions are neither too hot nor too cold to support life. For instance, if a planet orbits too close to their respective suns, surface water evaporates into space. The planet is too hot, and the conditions for a habitable zone are not met. On the other side, a planet might be too cold. This is the case for planets orbiting far from their host star. In this zone, any surface water remains frozen. Size also matters. A planet that's too small can't maintain an atmosphere. One that's too large will have a crushing atmosphere. A recently detected planet 493 light-years from Earth, Kepler 186f, is close to Earth's size and is located in its solar system's habitable zone. As of today, most confirmed exoplanets are much larger and hotter than Earth, characteristics that make them relatively easy to detect but not interesting for the search for life. Unfortunately, most of the planets found in the habitable zone turned out to be flops, in the sense that follow-up studies show that they are not able to host life. For instance, one of the most promising planets was Gliese 582c, the first super-Earth found in the habitable zone. However, this planet was later found to have extreme surface conditions that may resemble Venus. That's all for this video. What do you think about Kepler 22b? Let us know in the comments below. And if you enjoyed the video, don't forget to share it, and I'll see you